So in question number 1.19, we have a point charge of 2 microcoulomb is at the center of cubic Gaussian surface 9 centimeter on edge. What is the net electric flux through the surface? So this is a cubic Gaussian surface of 9 centimeter edge length, and at the center you have charge Q. So we have to calculate the flux through the surface. So obviously the flux will be Q by epsilon naught, that is from Gauss's theorem. So Q is given to be 2 microcoulomb, so 2 into 10 power minus 6. Epsilon naught is 8.85 into 10 power minus 12. So this, on solving, we get 2.26 into 10 power 5 Newton meter square per coulomb. So this is the flux. So in question number 1.20, we have a point charge causes an electric flux of minus 1 into 10 power 3 Newton meter square per coulomb to pass through a spherical Gaussian surface of 10 centimeter radius centered on the charge. If the radius of the Gaussian surface were doubled, how much flux would pass through the surface? Okay, so this is the spherical Gaussian surface, and this is the charge at the center. Okay, and the flux is minus 1 into 10 power 3 Newton meter square per coulomb. Okay, so this is the flux. Okay, now if the radius of the Gaussian surface were doubled, so if this is r and if the radius is doubled, so say this is twice r, even the flux is not going to change. Okay, flux is independent of the size of the Gaussian surface, so flux is going to remain same. The second part is, what is the value of the point charge? Now flux from Gauss theorem, it is 1 by epsilon naught times the charge enclosed. So here Q is at the center, so Q is equal to phi times epsilon naught. Okay, now phi, the flux is given to be minus 1 into 10 power 3 and epsilon naught is 8.85 into 10 power minus 12 is 8.85. So this, on solving we get minus 8.85 into 10 power minus 9 coulomb. Okay, so it is a negative charge. Since the flux is negative, charge is also negative. So this is the final answer. Now question number 1.24 says that you have two large thin metal plates which are parallel and close to each other. On the inner faces, the plates have surface charge densities of opposite signs and of magnitude 17 into 10 power minus 22 coulomb per meter square. What is the electric field in the outer region of the first plate, in the outer region of the second plate, and in between the plates? So these are the two plates. Okay, this plate is having positive surface charge density and this plate is having negative surface charge density. So this is plus sigma and this is minus sigma. Okay, so electric field in the outer region of the first plate. So this is the first plate, this is the second plate. Outer region of first plate means this side. Okay, so for this surface charge density, electric field intensity at this point, due to positive charge, it will be in this direction. Okay, this is E plus sigma due to these charges, and for these negative charges, electric field intensity, it will be in this direction. So this is E minus sigma. Okay, and magnitude of this E plus sigma, it will be equal to E minus sigma, that is equal to sigma by 2 epsilon naught. Okay, so that is, the two fields will have same magnitude but they are in opposite direction. So here the resultant field will be 0 in the, so the answer is for the, what is the electric field in the outer region of first plate? So in the outer region of first plate, the electric field will be 0. Now similarly, if we see this side, this point, so for this negative charges, electric field is in this direction. For these positive charges, electric field is in this direction. So again here also the resultant field is 0. Okay, now in the region between the two plates, for this positive charges, electric field will be in this direction. So this is E plus sigma. Again for the negative charges, again the electric field will be same direction. So this is E minus sigma. So for both this charge and this charge, the fields are in the same direction. So the resultant field E will be equal to sigma by 2 epsilon naught for this plate and sigma by 2 epsilon naught for the negative plate. So this is sigma by epsilon naught. Now surface charge density, it is given to be 17 into 10 power minus 22. Epsilon naught is 8.85 into 10 power minus 12. So this, on solving, So this on solving, this is 1.5 into 10 power minus 10 Newton per coulomb. Okay, this will be the answer, but here in your NCERT the answer is given to be 1.5 into 1.5 Newton per coulomb. That is this surface charge density, instead of 10 power minus 2, it should be 10 power minus 12. Okay, then the answer will be 1.5 Newton per coulomb. Okay.